Today, my topic is on the Skyline Plaza collapse in Fairfax County, Virginia. The date of the collapse was in March 2nd, 1973. Of this PowerPoint, we'll have detailed case study, a summary, and solutions to fix the collapse. Slide I will be giving you a background of the Skyline Center complex located near Bailey's Crossroad in Fairfax County, Virginia. It was planned to contain 6 office buildings, 8 apartment buildings, namely A1 to A8, a shopping center, and a hotel. Figure 1, you will see the Skyline complex that has 2 apartment buildings that were completed. You can see a pair of apartment buildings and adjoining parking lot and lobby structures under the construction, which is right here. I will be giving a description of the structure. The 3 structures under construction were designed under the Fair County Building Code ordinance, which incorporates by reference the provisions of ACI 318 through 363. And Building A4, the Skyline complex contained reinforced concrete and was constructed with a flat plate, supported on 4-foot thick foundation mat. Apartments were to be located 26 stories from the finished building, along with a penthouse and a 4-story basement. The typical story height from the first story up was 9 feet 0 inches from the top of the slab. The floor slab was 8 inches thick. Continuation of building A4. The total basement height was about 40 feet as measured from the top of the foundation mat from level B4 to the top of the first floor slab. The plan view without the parking garage plan shown in figure 2 is that of the 22nd story and is typical for the first floor through the 26th floor. And the column layout. Figure 2, you are going to see there are 8 shear walls which I've circled in red. There is also a 1/2 inch expansion joint that I've circled here green, which is H. This is the Skyline Plaza area view. Here you're going to see marked in red where the collapse happened. This photo was taken at 11 a.m. on March 2nd, 1973, just before the collapse. We will be going over the skyline design, strength of the concrete. Let's begin with floor base 1 through 7th. Here you can see that the slab on these floors are 3,000, 20.7 MPa. The columns are 5,000, 34.5 MPa. From the 7th floor to the 17th floor, the slab stays the same. The columns do change. They go 4,000, 27.6 MPa. Now from the 17th floor to the top of the floor, it's the same for the slab, but changes for the columns. The columns go to 3,000, 20.7 MPa. Going over an overview of the collapse. The collapse occurred around 2:30 p.m. on March 2nd, 1973, while under construction of the 24th floor slab was being cast. Shortly after lunch, some workers observed slab deflections of approximately 150 to 600 millimeters, which is 6 inches to 2 feet, for both the 23rd floor slab and the freshly placed 24th floor slab. The freshly placed section of the 24th floor slab then fell into the 23rd floor slab, starting a collapse that continued all the way to the foundation. The building's collapse removed the edge support from the parking garage, and falling debris triggered the failure of the garage. Here, in figure 5, you will see the skyline floor plan. This is the 22nd and the 23rd floor, which shows the approximate area of the collapse, which you will see here marked in red arrows, and here. This is a real close-up of the skyline damage. You can see here that it started from the top and gradually, floor by floor, started collapsing and coming down. You see a partial view of the north face of building A4. On the north face of the collapse, extended between columns 12 and 17, you're going to see a distance of about 104 feet from here to here. The number of columns and floors are identified. The collapse extended between the shear wall H and the column 33 on the south face at a distance of about 65 feet. Here goes column 33. See a general view of the skyline building A4 as seen looking towards the southwest. Station from the collapse. Once the section of the apartment building collapsed, the failure propagated horizontally through the attached parking garage. This resulted in the death of 14 construction workers and the injury of 34 others. Of the workers killed, 10 were in the tower and 4 were in the garage. Investigation of the Skyline Collapse. The U.S. Department of Labor's Occupational Safety and Health Administration, also known as OSHA, case files and information from on-site inspections by National Bureau of Standard Inspectors have been used to study the collapse of the Skyline Plaza apartment building A4. Slide, I highlighted the formwork. Here you can see from level 22 to 24. You can see right here, the showing, holding it up. Previous figure, it shows the locations of the formwork from March 2nd, shortly after the collapse. Full formwork was placed on the 24th and 23rd stories in sections 1 and 2. Some formwork may have been seen in the 22nd story in sections 2 and 3. Full formwork was also in place under section 4 on the 22nd and 23rd stories, but there was no reshoring that can be seen under section 4 below the 22nd floor on figure 9. Here I will be going over the formwork shoring and reshoring for the Skyline complex. According to OSHA regulations, ANSI 810.9 sections 6.3.2 and 8.1.5, it is required that a lateral bracing system is capable of resisting a lateral force of at least 2% of the dead load of the slab. There were stringers erected with a shore under each end, wherein the stringers was inserted in a basket-like socket connected to the shore. Stringers and joists were usually 16 feet long, although some were as short as 6 to 8 feet. The formwork sheets submitted to Fairfax County contain no mention of lateral bracing for the form system. However, a limited amount of bracing may be seen in figure 10 in the next slide. You will see diagonal lateral bracing was installed after every fourth shore at about 16-foot intervals. Figure 10, you are going to see formwork in sections 1, 2, which would be here, 1 and 2. For reference, several sections have been identified. You will see here 1, 2, 3, 4, 5, and in 3 you don't see no shoring at all. Here you can get a better picture of the stringers and the joist. Here you're seeing the reshoring in section 2 of the 22nd story as of March 6th. There is conflict in their statements. A number of workmen that escaped the building by way of the stairs in Section 4 have indicated that the 22nd story was either partially or entirely stripped in Section 3. Photographs taken right after the collapse showed that while full shoring remained on the 23rd and 24th stories, it had nearly all been removed from the 22nd story in Sections 1 and 2 but remained in Section 4. According to OSHA regulations, forms are required to be in place for a minimum of 10 days with temperatures greater than 50 degrees Fahrenheit for spans longer than 20 feet. ANSI A10.9 section 6.48. The engineer's structural drawing required 2 full stories of shoring and 1 story of reshoring while a concrete slab was being cast. Here, during the NBS site inspection, a considerable portion of the lumber used for the remaining forms in the 24th story was found to be in poor condition. You can see right here, or it was out of plumb. So, the photograph illustrates a shore that is out of plumb and has a vertical crack near the top. According to OSHA regulations, this requires correction of this condition prior to placing concrete, which is not yet placed on these forms. In this picture, you can see the correct way. Case of the 24th story, OSHA regulations required correction of these conditions prior to placing concrete. Here you're going to see the same thing is happening on the 23rd floor, where the wood is apparently damaged and reused. If you can see here, this is not even correct. Piece of the 2x4 is missing. We are looking north of the building. This is an estimation of the location of forms and reshores at the time of the collapse. Here you're going to see there's missing reshoring and there's missing reshoring here. So this is where the problem possibly could be. The laborers on site, one concrete finisher working near the stairwell around columns 65 and 66 indicated that a large deflection was seen in the middle of section 3. However, the middle of section 3 is about midway between columns 67 and 85. The statement of one worker gave the investigators a good idea of the state of the forms at the time of the collapse. One workman indicated that at the time of the incident, he was placing reshores in section 3 of the 21st story, that some reshores were present when he started working. Prior to the incident, all the reshores fell out except those on the balcony areas. This is consistent with what could occur if the forms had been removed in the story above. If the shoring had been removed on the 22nd floor, the 22nd floor slab would have been relieved of its previous loads. With less loading, the deflection would have decreased in the slab, causing the reshores on the 21st floor to fall out. Concrete and Skyline. According to OSHA regulations, required field-cured cylinders stored at the same temperatures as the structure to verify the strength of the structure before removing shores and formwork. The results of standard ASTM C39 concrete cylinder tests showed adequate strength at 7 and 28 days. However, these were laboratory tests with cylinders stored at a controlled temperature. Particularly in cold weather, laboratory tests do not correspond to the strength of the concrete in place in the structure. Failure. The premature removal of forms supporting the 23rd story slab when the concrete of the slab had a relatively low strength produced shear stresses. that were in excess of the concrete capacity at the time of the incident. The most likely mode of collapse has been determined to be a shear failure around columns 67, 68, 83, or 84. The accumulation and impact of debris from the 23rd and 24th floor slab would have overloaded the 22nd floor slab and induced progressive collapse of successive floors to the ground. The collapse is believed to have started with shear around columns 67, 68, 83, or 84. The loss of support from any one of these columns would lead to overstressing of the remaining columns. Investigation of failure. The three-dimensional elastic analysis was performed using the finite element analysis program known by the acronym SAP. The evaluation of the capacity of structural elements was based on the provisions of ACI 318-71 code and on procedures from public, analytical, and experimental research. Each of the three finite element analyses had a particular purpose. Case 1. Some of the employees state indicated that the 22nd story forms were entirely removed at the time of the collapse. Case 2. The concrete is to have attained its full 28-day design strength of 3000 psi. Case 3. Some of the employee statements indicated that the removal of shoring under the 23rd floor slab in the central corridor area of the building was in progress on the day of the collapse. The investigation to the shear failure. Upon examination of all the probable conditions prior to the collapse, it is included that the initial shear mode of failure of the 23rd story floor slab resulting from partial or complete removal of shoring prior to the incident was a major contributing factor to the collapse. Here you can see for column number 70, 67, case 1, this is the max PSI and the required PSI. This is the estimated PSI of the column. For 68, you can see the same, as well as 83 and 84. Of the PowerPoint. An analysis of the 23rd floor slab indicates that its most likely mode of failure was in shear around one or more columns in section 3 of the floor slab. The strength of the 23rd floor slab on the day of collapse has been found to be a magnitude that completed or partial removal of shoring underneath the slab would have produced a shear failure in the slab. The weight of debris resulted in failure in the slab below and carried through the heights of the building. There was a non-compliance with OSHA regulation. First, there was the pre-removal of the 22nd story form. The forms removed on the 22nd story were in an area with spans exceeding 20 feet and therefore should have been in place for 10 days of temperatures exceeding 50 degrees Fahrenheit. Shoring in section 3 of the 22nd story, the architect's specifications required in all cases 2 floors shall be fully shored. The removal of the 23rd story forms left only 1 story of form in place under the recently poured 24th floor. Lateral bracing minimum values of 100 pounds per foot of floor edge or 2% of the total dead load of the floor, whichever is greater, is required. No evidence has been found which indicates that the lateral load was considered in the design of forms. The lateral bracing provided would not provide this resistance. 1. The shoring was out of plumb. 2. The shoring was damaged. And 3. There is no inspection. Solutions to fix the collapse. Let's begin with the engineer of record. They should make sure he or she provides the contractor with all necessary design loads, data, and other unique project information. Uncontrolled acceleration of formwork removal may cause a total or partial collapse, and continuous top and bottom slab reinforcement is necessary around the columns. Continuous reinforcement provides overall ductility. Inspectors and other quality control agencies should verify that the contractor performs the previous 2 items. The contractor should prepare a detailed concrete testing plan for stripping forms, including cylinder tests. The contractor should be responsible for preparing formwork drawings, including shores and reshores.